Hi everyone, I am Dr. V.S. Nishok from AC Department, SNS College of Technology. Here we are gathered to discuss the topic comparator from the subject linear integrated circuits. This is the outline of this video. It starts with why do we need a comparator. So it continues with problem definition, basic comparator circuit and types of comparator and its practical applications. So we are starting with why do we need a comparator. So generally, while measuring the physical quantities like temperature, humidity, pressure, etc., the sensors are used and it obtains the signals as analog signal. And the controller needs the digital signal for processing. So here the system needs to decide whether the obtained analog signal is below or above the given reference level. So here there is no calculation, so only the comparison between the input signal and the reference signal is needed. So by using the operational amplifier, so initially we will think it as an amplifier, but we can use it in open loop configuration for comparator circuit. So here in order to compare the input signal, analog input signal from the sensor and the reference signal and obtain the output in the digitalized, that is binary level. It can be obtained with the help of this operational amplifier by connecting it in the open loop configuration, which will perform its function in a high speed and reliable condition. So by the help of the IC741 op amp, we can go for the no feedback circuit. So that is no path between the output and input terminals, which provide the high gain in the output. So coming to the types of comparator. So here with the help of the IC741 IC, we can go for inverting comparator and non-inverting comparator are the main types of the comparator. So here when the analog input signal from the sensor is connected to the inverting terminal, so then it is called as an inverting comparator. So in the other side, the reference signal will be connected to the non-inverting terminal. So here Vin will be greater than the, if Vin is greater than the V reference value, then since it is connected to the inverting terminal, the output will be the minus reset. So that is negative peak. Output will be obtained at the negative peak. And then if it moves to the, that is Vin moves less than the reference value, the output goes to the positive peak. So that is plus reset and minus reset. Similarly, coming to the non-inverting comparator. So coming to the non-inverting comparator, the analog input signal will be connected to the non-inverting terminal and the reference signal will be connected to the inverting terminal of the operational amplifier. And coming to the practical application, it starts with detectors like zero crossing detector, level detector and over voltage protection, and it is very well used in the A to D converter stages, input stages, and then pulse shaping circuits. So everywhere we can use this operational amplifier as a comparator circuit with the open loop configuration. So coming to the summarization part, so we have seen why do we need a comparator and what is the configuration we can connect with the help of the IC741 operational amplifier. We can use it as a comparator, and what are the types of comparator. The main types of comparators are inverting and non-inverting comparators, and coming to the practical applications. So this is the time for assessment. In a comparator, the op amp is operated in open loop mode. So op amp is operated in open loop mode, that is called as a no feedback mode. So that is the right answer. And coming to the next question, why does a comparator output saturate? So due to the very high open loop gain, so due to the very high, as already discussed, it provides the high gain at the output part. So because of this high gain, so it comparator output will be saturated, that is moves between the positive peak and negative peak values. So this is the reference books that we used for this video. So thank you all for joining this video. We can join in the next video.